Okay, here we've got a setup looking at the pressure law, or the Gay-Lussac law, and we've got a pressure gauge here. It's an absolute pressure gauge in bar. It's not too difficult to convert that to pascals, but to be honest, you don't need to convert it, I suppose, if you're just looking at trying to find absolute zero from the graph. Okay, so you've got 92.1 degrees there. You've got the pressure and the temperature, and we're going to it's all on a fixed volume. We're going to cool this down and see what happens in terms of the data points, and see if we can extrapolate back to absolute zero. I put 2 kettles full of boiling water into the vessel there, and the temperature lag has stopped now, so it's stopped rising, and so it's starting to cool down now. We might add a bit of ice to promote the cooling a bit faster. But if you take data points at various sections throughout here, then you should be able to plot a graph of pressure on the y-axis and temperature on the x-axis, and then extrapolate back with a line to around about minus 273 degrees Celsius or absolute zero Kelvin, depending on what axis you choose. So we're going to try adding a bit of ice, not near the sensor, but to try and promote the cooling a little bit. It says not near the sensor, and it's gone right next to the sensor now. Won't make much difference really. A small amount of ice in that huge volume there. The point of this video is I thought we could speed watch it, or you could look at various points and just take some data points across the range of room temperature to 90 odd degrees Celsius. You're still only going to have a very bunched set of data points, but unless you use a coolant like liquid nitrogen or something, which could be used here with this vessel. When we get hold of some liquid nitrogen, I might do this video again, and then we'll have a much larger data set then. You can see as the temperature's going down, the pressure's going down. I left a bit of water, a bit of gap here, so that when it displaces with the ice, it won't cover the sensor, the end of the sensor. So we're down to 78 now. The other way of doing it is this was with maybe a hot plate underneath. But I usually find it's more leisurely if you start cooling as opposed to heating. Just trying to keep the ice away from the sensor. Now, I've not done this before, so I'm really not sure how good we're going to get in terms of the graph, but I'll plot it and I'll put a link to it in the caption to the video or the Twitter post. Oops. Move the video. We should eventually get down to around 1 bar here. Well, I think I've reached about the limit, really. I'll just raise that up a little bit further. But I don't really want to damage the temperature sensor by raising the volume of liquid too high. One thing I could do now is extract some of the water, I guess. Be interesting to see how good this is by taking these points. You could always, if you were doing this with an A-level class, you could always look at how it's good to video or take a photograph of the two variables so that you get the match. If it's a quick changing thing, this is not a very quick changing experiment, obviously, but for some of the electricity experiments where you're trying to measure voltage and current at the same time, then taking a photograph is really useful. I might just see if I can add a little bit more ice. See what the limit's going to be here. There, I think. Just raise this up a little bit more if I can. what I've just remembered that I have here is a large syringe. So I might remove some of the water and then add ice just to promote the cooling. Just take it down a little bit so I can add some more ice. Otherwise it'd be the world's longest video. There we go, that's quite a bit. Let's add a bit more ice. Plenty of ice, and this is nice, useful ice to have. Again, another reason why I'm videoing this is because in a class you wouldn't want to get a class to sit still for 12 minutes so far, waiting for this to happen. We've got a Jolly's bulb set up which I'll demonstrate in a class for this, but I just thought this might be a useful video to supplement the Jolly's bulb demonstration. I should talk about this vessel here. So this vessel is sealed, so it's fixed volume, and nearly all of it is immersed. Almost all the volume is immersed inside the container there. So at the moment we've got 53 degrees Celsius, and we're getting down now in pressure quite considerably. So pretty soon it won't be an issue about covering the plastic of the thermometer, really. Okay, so that'll be useful. In fact, probably about now it's probably okay, really. I might still take a little bit more water out over the syringe. But I probably only have to do this once or twice more now. There we go. So when I plugged this instrument in, it was around 1.002 or something like that at room temperature. So, although we can cool it down beyond room temperature, maybe. Depends how long this ice lasts, really, I suppose. Be nice to be able to get it under a 1 bar. It's also, pressure is a good topic to talk about units. You know, there's so many different units of pressure. Lots of students are familiar with PSI, pounds per square inch, bar, millibar. Less so. Millibar used to be on a lot of weather forecasts when they used to show pressure maps on the general BBC weather forecast a long time ago. But it tends to be PSI seems to be the unit that most students are familiar with from tyre pressures, things like that. But of course Pascal's is the unit that they need to be using in exams generally. Newtons per metre squared. Although in an LXLI GCSE, the course we do, quite often they can sometimes get away with newtons per centimetre squared depending on how the question's phrased and laid out. In America they use torr quite a bit, and then there's always the millimetres of mercury in some of these more historical units. Right. Let's just keep that away from the temperature sensor a little bit. Still got about half the ice left, which is great. I think I'll still remove some of the water when the ice is melted in the current batch. I think this is definitely my longest, oh no, it's probably not the longest video. I did some videos about teaching various A-level topics and they would have been a lot longer, I guess. I notice on here there's a limit of 30 minutes on video on my phone camera, so I'll have to try and keep it under that, which shouldn't be a problem. Right, let's wait for that to melt. Also a good opportunity to talk about mixing and stirring. It's not ideal, this experiment, because I haven't really put a stirrer or anything in there. But if I was to do it again, I would. Right. Let's just remove some water again. A little bit more. Can't really remove much more because I don't want the main volume to be exposed to the air. So we're down to bath temperature now, I guess. I think. Oh, that'll still be quite a hot bath. Okay. A little bit more water out and a bit more ice just to hurry things along. Going to start putting in quite a bit of ice now. Try and keep it away though from the temperature sensor. I'll do that. Yeah, I'll probably stop the experiment just below 1 bar. And then I'll go and plot the graph. Could be the video that nobody ever sees because it doesn't get anywhere near absolute zero. Should do, I think. Proof will be in the graph though, as ever. This is a useful glass container here, isn't it? It's we bought this in specially for another experiment, another demonstration. But very tall glass beaker, which has been really useful actually for this. Oops, temperature. Not sure when that went off. Still quite high, 40. I'm going to start putting quite a lot of ice in now, although the volume of the water is so large that the ice is only going to bring it down so much, really. Let's have a look. Right, so 39. Yes, I think if I kept this going now, it's probably not going to get down to room temperature within the video limit of my phone. So I think I'm going to have to stop at some point soon, I think. Just take a little bit more. I would have liked to have got under a bar, but the amount of water you're having to cool there, it's not going to make much difference, even the rest of the ice being put in now, even if it was at room temperature. I think we might struggle to get down to freezing. Not freezing, to get below 1 bar. Just take a little bit more water out and try it again. Okay. Okay, let's have a look. I'm going to put most of the rest of the ice in now and see where it bottoms out. Although, obviously, if you left it long enough, it would reach room temperature, but we haven't got that time today. And it shouldn't be that important if if we've taken data well so far. We should be able to extrapolate, even though it's very bunched data in the grand scheme of temperatures. It should still be pretty good, I think. Away from the sensor a bit. So down to 33. There's not much ice. This is the last couple of chunks now, so let's see how this goes. Okay, so at 22 minutes, I think we'll probably leave it around there, okay? The last data point. Maybe leave it till 30 degrees and then I'll stop it, okay? Tiny bits of ice here. Okay, so I'll stop it now in a moment at 30, and we'll see how this goes when we plot it.